Hello there. Good morning, folks. Thanks for joining the talk. Also, pardon me if I sound really tired. It's been an awesome 3 cities conference with DataEngBytes. That's to say that I spent the time hopefully talking to people about MLOps, not partying in between cities. But anyway, so featurization and feature stores. One thing I do want to caveat is, first off, this is 140 slides. So do not try to take photos of every slides. Why? Because I send a link to the slides after the talk. Because I also want this to be a little bit interactive as well. And I want you guys to just soak in the vibes. You know, don't worry too much about the details. So we're going to try to answer a couple different questions, but feature stores. So I do come from a feature store company, but in my opinion, there's a couple reasons why I don't really want to pitch you a feature store, and why I'd really rather talk about how feature stores fit into the MLOps ecosystem. And the first part is feature stores are not really a well-known category. So I think there's a lot of education that needs to happen there. I also think feature stores are not necessarily the right tool for every data science team. There are certain maturity points you want to hit before you even consider it. But more importantly, like MLOps at the end of the day, it's about solving the key problem of making things better, faster, less risky for your data scientists. So she already mentioned my background. So I've worked as data analyst, data scientist, and MLOps engineer for a bunch of different companies. The names of these companies are not really super important. But the part that I think is most useful is the fact that I've worked for early stage startups. I've worked for mid-size. I've worked for enterprise. I've worked at companies where they try to say, hey, we have a data mesh architecture. It's like, no, you just have a mess. So a lot of hard-won experiences that got me to these insights. And one of the things that I think is really important is, first off, grounding people in what is the difference between ML and data analytics. Like, what is the key problem there? Because a lot of times we'll get questions like, why can't we just use GitHub for versioning, code, data, and models? And there are reasons why. Now, both data analytics, data engineering, and ML, you could argue, is all about taking data and creating something useful out of it. But the form of what is that useful thing is way, way different. Apologies about the formatting, but hopefully you can still see what this says. And namely, if we think about data analytics, data science, and even where data engineering kind of fits into the whole thing, there's a couple different levels that you kind of go through, whether you understand it at the time in your data to ML journey into the adoption, right? The first part is you have to understand what's going on, and that's where data analytics tools and initiatives usually kind of fall into. They just need to understand what the hell is going on in the business right now. But that is a slightly different beast from saying, okay, now we need to figure out what could happen, the predictive side. And eventually, which is where MLOps comes in, is you want to take those ML artifacts and you actually want to do some automation with it. Whether that is telling people what to do or whether that is doing things for them. And that's a really key difference, those different levels, the P's and the D's. Now that comes out of the fact that before, right, so DevOps. People could argue that there are a lot of similarities, right? You take code and you apply it to data. And already directionally there, that is in fact not what ML software looks like. We all know this. I know I'm just kind of preaching to the choir at this point. But I think it's important to really ground ourselves in these subtle nuances because they do impact the way we design our tooling and the way we combine that tooling to design, hopefully, great user experiences for data scientists. And namely, it's that the code that is generated comes from the model, which is driven by the data. Now, I think it's important for us to all agree on what does the ML lifecycle look like, because especially recently with the arrival of LLMs and a lot of generative AI onto the scene, people are getting a little bit confused. So the model development phase, right? First thing to understand is that all these stages are cyclical. Now, I've sort of limited down here just for the sake of having a framework, a way of approaching the world. But like they say, all models are wrong, just some are useful. Now, most people have experience to this, but ML projects don't just come out of thin air. Especially in an enterprise setting, you have to do a lot of negotiating, you have to do a lot of buy-in, you have to do a lot of scoping and requirements gathering before you can even get to any sort of model work. Hopefully, you are getting your RACI chart, responsible, accountable, consultant, informed. Hopefully, you are doing some kind of feasibility analysis. And of course, you do some training, and at some point, you push the model out. Now, this is the part, obviously, that a lot of companies have trouble with. Even at MailChimp, even at Intuit, even at Sunrun and Teladoc, we had a lot of issues here. Because it's very easy to say, hey, we're gonna do this new cool thing, but once the shine of it has worn off, I mean, who really wants to kind of, I don't know, watch out for airflow notifications? This job has failed. You just ignore Slack at a certain point, right? It is a very messy process. A lot of decisions have to be made. Now, the interesting thing, of course, is when we say pipeline, it is a little bit of an overloaded term in some ways, right? Because for a data engineer, a pipeline means you go from aggregating a bunch of sources, you clean it, hopefully you do some data modeling, and then you present it at some point. For a data scientist, it's like, well, yes, but that clean data that you said is, meets all the kind of the quality checks, like fits that schema really nicely. We still have to do a lot of stuff to it. And another challenge is that there is no correct way to deploy models. There are plenty of patterns that work just fine. So, for example, a classic one is a batch prediction pattern. We use this for 80% of our models at MailChimp. And guess what? MailChimp was purchased for $12 billion by Intuit. As an employee, I did not get any bit of that money before you ask. That's why I'm here talking to you. No, I'm kidding. But it worked for a majority of our use cases, and MailChimp was very heavily an NLP-like company in terms of data science. Not Intuit, MailChimp. Intuit did a lot of other stuff too. Model as a service. This is also a very great pattern. For example, when we wanted to do in-app recommendations, so a customer, a small, medium-sized business, maybe they're selling mittens on Etsy or something. They're like, hey, we want to come up with a social media campaign that also does email that does XYZ. We need to kind of build this campaign journey. Okay, great. So in MailChimp, we said, hey, let's recommend you some journeys and steps to add on to your sequence. We use a service pattern. It was fine. Now, I did mention that we were going to talk about feature engineering and feature stores, largely because this is the part that, frankly, still kind of sucks for most data scientists. 80% of your time is spent on doing data things. And for the most part, this is also the part that still has yet to be automated very well. And there's a couple reasons why. For one thing, data science ML models are dealing with so many different kinds of data, right? There's your classic time series data, which is frankly kind of clean. But then you also have unstructured data like text, images, all that stuff, right? You can have a multi-model system that actually incorporates all of these at some point in time. Now, first step to get there is you have to clean it, you have to transform it, you have to do EDA. The funny part of the switch to AI and ML adoption that you can tell we are more mature is when people were first getting started, they were like, yo, yes, let's put ML in everything. But now the advice is just try not to even go there. If you can just do a dashboard, generate some actionable insights for the business. You don't need an ML model for that. And that's how you can tell things have actually matured, because before we just wanted to have everyone buy into ML. Now we're like, it's okay. Now, just to be clear, when I say feature engineering, and this is relevant for LLMs, a feature is just any input into a model. Doesn't have to be text, doesn't have to be numeric, could be anything. Could be embeddings, could be prompts. Feature engineering, right? So this is kind of what it looks like roughly. There's so many different things you have to do. A lot of people still do hand-tuned features, and there's a number of reasons why. For one thing, You can automate that code pretty easily. For another thing, feature interpretability, model interpretability. You can measure the distribution changes. You can also kind of figure out what you do or don't want. And if you already have the existing domain expertise, it sometimes is pretty quick. You just copy pasta code. I'm sure all of us haven't had to deal with people copy pastaing PySpark functions or Python code or anything. I'm sure no one has sent snippets of code via Slack, right? No one's done that. You've always put into GitHub, sent someone the link to it. Training and deployment is actually a relatively solved problem because this is basically a software engineering problem. It's not that hard. All this leads to being a system of loops with a lot of steps, much like a choreographed dance. So what is MLOps actually supposed to be doing here? Now, part of the argument that people have about why you should buy MLOps tooling is that it is a significantly different problem from DevOps. But a lot of people are like, yo, they're kind of similar. And part of the challenge also is that we don't have a really sort of standard definition. Or maybe we do, and people just need to keep writing Medium posts. So we just keep saying there's different things, right? But I think people can kind of understand what MLOps should feel like. They might not be able to describe it, but they understand what it should intrinsically feel like. For now, let's just assume that this is the definitions that we're going to run with. That ultimately, the goal eventually is to create nice abstractions for data scientists to use that will actually speed up their work. Now the XOps family, I've been told that this term XOps is very triggering, and I'm sorry, but we're just gonna run with it. But there are all things that, DevOps, DataOps, MLOps, they should be solving, and they do share common characteristics. For one thing, life should feel a lot easier when you're, developing a data pipeline, when you're developing an ML pipeline. There are certain core metrics that should be improved as a result, certain sort of business objectives. For one thing, you should have people moving faster, time to deploy. So the minute they understand what model they're trying to build or what the use case is, they should be able to get through that pretty quick. Scully from Google, I think he said aspirationally they want to have a data scientist or MLE, or even a software engineer, actually. He said a junior software engineer out of college. They want her to be able to deploy the model in 6 days. Now, I can tell you most companies do not accomplish that, even ones that have been doing ML for a very long time. It's very aspirational, but they drive to that as a North Star. I believe Shopify, I have a friend who worked on the Merlin platform, and he said that it took him 48 to 72 hours to get a model up and running and deployed into their prod. Well, it's not really a prod. It's their sandbox prod, But 48, 72 hours. I mean, who currently here is deploying models that fast, or whose data scientists can actually do that? Actually, quick question is who actually works with data scientists? Indirectly. Okay, fantastic. If it was no one, they'd be like, oh, maybe that's actually a dumb question to ask. But okay, so point still stands. And then last part is risk. Minimizing that. No matter what, regardless of whether you're doing tools, whether it's different teams, it should all come up to this beautiful experience. So how is MLOps different from DevOps? Right, so let's go back to this. You don't see a lot of this in traditional software. And by a lot of this, going back to the data drives model drives code, software is basically code tested on data, and then you go there. So already these 2 steps, not covered in most traditional DevOps tooling. More importantly, you will have multiple versions of those. Sometimes the same feature pipeline is going to feed into different models. It's not super easy. Now, one of the earliest realizations of this was in 2014. Well, I don't say it's an early realization. The people who got to put their name on MLOps that coined this famous diagram was the Google folks. 2014, they said, hey, there's actually a lot of stuff that has to go on. And then in 2016, 2017, they said, hey, by the way, they did some internal analysis on this one project that they will not name, that they said kept breaking hundreds of times over the years, which I think is really funny because I think most people can probably know or guess what project that was. They said it was one of their oldest ones, probably related to search. And one of the beautiful things they did was they said, hey, look, there is, in order to make something reliable and for users at scale, there's a lot more you have to do, not just in terms of tooling, infrastructure, but actually tests, monitoring, all that great stuff. Now, of course, people also, when they think about MLOps, just like when you think about DevOps, it's not just a tooling problem, it's also a culture problem. It's a documentation problem, it's a knowledge problem. For example, you don't want undocumented tribal knowledge. You don't want to keep getting closer and closer, much like in calculus, you approach a limit and then you never actually hit it. Slack fatigue is a real thing. I know at some point, unfortunately, month 2 or 3, I just basically muted the Slack notifications channel because I figured if it was more important, the data science would just ping me directly. That was a pattern we all did. Insufficient data documentation. Everyone has had that experience of taking 2 to 3 months to get up to date on Confluence, which is where knowledge goes to die. And it's funny because when you do these surveys over and over again, some of the same challenges come up again as having not been solved problems. You have to know a lot about MLOps, and it's not just about ML, but it's also the connection to data. And you also have to care about your users. You have to care even if they came out of a boot camp, even if they just use a bunch of jargon, even if they're like, no, data drift, no, train test skew. You do have to care about them. Because they bring a lot of knowledge and experience to the table that, in some cases, when you're dealing with small data, is actually more important than when you're dealing with big data. Like statistics. Like, for example, if you're not Google, let's say, for example, you're a data science at Teladoc, once upon a time ago, you're dealing with a product that focuses on people with chronic conditions like diabetes, and you're told, hey, we need to come up with new behavioral therapies, usually in the form of email campaigns, knowledge is power. And you're told you only have 75 to 125 people that you can work with to determine whether or not that quote-unquote experiment was useful. Guess what? Calculating sample sizes, statistical significance, and power matter a lot. They don't matter when you're dealing with millions of data points at Google. And it's not just data scientists are bad coders, right? They do bring a lot of knowledge to the table, come from a lot of experiences, which means that you have to design interfaces that deal with lots of different people. Lots of different places that they come from, and they've also started specializing a little bit more. Oh, of course, let's not forget the data engineers, the true heroes of ML. You can't have ML without data. You also can't have ML products without lawyers, too. I think maybe people forget about that. Lawyers, product managers, business people, your business partner that goes to bat for you to say, hey, this is important, much like in public health. It seems to only matter after someone's died from water contagion issues. But we really don't thank the people who are like before that, oh yeah, it mattered. But there are challenges MLOps hasn't solved. So for example, even if this is a working system, it's a little bit painful for someone to still traverse. Like if it was this clean, people wouldn't have problems and I wouldn't have a job. Privacy, access to quality data. Still same issues. Latency, architecture is good for certain AI/ML applications, not others. And from the data science perspective, oh my God, you're having me do all the software engineering stuff. Why am I even a data scientist? I could have just been a software engineer. Now, some people say it's because of the tools. What's that whole thing about a clock? Broken clock is right twice a day. I mean, this is what we had before. I'm sure many of you remember having to set up a Hadoop cluster just to get like business analytics. So I don't know. It feels like we have a lot of options. And of course, most people just kind of revert to this anyway because it works. Like Tupac said. Tupac and Biggie Smalls. Actually, it was Biggie Smalls who said that, but. This idea of more options, making people happier, more satisfied, yeah, that's not actually the case. This is true with jams, even though there is a correct answer, which is any jam that has this red and white top is the correct flavor to choose. But still, people, they will choose other options. But more importantly, the more options you expose them to, the unhappier they are, and the more confusion there is. So really, I think the problem that MLOps is solving right now, it's actually more of a workflow and organizational problem. We've solved that. So feature stores is a case study. Yes, I promised feature stores. So now that we have an idea of the MLOps, things that go right and things that go wrong, let's drill in on feature stores. So even though everyone's kind of in a different state of their MLOps maturity, 20%, right? 1 out of 5. That's the right fraction, right? Yeah, okay. So 1 out of 5 companies are building a feature store. So it's worth kind of diving into why they think it's even, wow, the formatting is epic. The formatting is epic. So what's the general goals of any kind of MLOps tooling? Decrease iteration. Handshake more. Things should break less. And if you're an enterprise, do not get sued for GDPR. Now, how are feature stores supposed to do this? For one thing, it's not just versioning data, it's also versioning the features, which is the outputs of the transformations and the metadata. Make things easier for data scientists. They should be written in Python. There's a bunch of other stuff they should do. So let's just take a feature transformation, drill in on that, right? And it's important because unlike data, you regularly toss away features. Core ingredients, you have a data source. Let's say for a fraud use case, you have your transformation. You have your inference store where you serve stuff out. And then you have your training store where you train models. So what this could look like, for example, that could be a transformation. They don't always have to be ugly CTs that are nested. Ideally, you want different variants. You want to be able to use multiple ones, and you want to chain them. You need to be able to do some kind of type reinforcement. You need to give a label. You zip all that together into a training set, which you then serve for model training. Now, because I took so many times to pause, I am going to have to speed run the rest of this real quick. So when you think about where feature stores or any MLOps tooling fit in, think about 2 dimensions. First one is the level of abstraction. The second one is where it fits in the ML lifecycle stage. Also, I gave most of this in Sydney. So a lot of this I actually covered in that talk. So if you really want more details, you could also listen there. But in terms of where feature stores fit in, also these are the questions you want to be asking. And this is what I say by we've solved all these problems. How fast predictions can be served. For example, Redis is a great in-memory store. Goes really fast, goes vroom. Whether it fits into the workflow. Whether a data science has to or can use the same thing to go from dev to prod. And this is ultimately where a feature store fits. Right there. It's not layer 0, layer 1, because that is where something like Kubernetes fits. That's where something like BigQuery fits. That's where something like Redis fits. That's where something like Spark fits. Airflow, all things that are used for general software development and support general software operations. If you need a market map, kind of, this is roughly where everything falls. But when you're building your platform, here's a couple guidelines. First off, think about who you're building it for. If you're a solo data scientist, these are the things you probably need. I know, that was quick. Don't worry, I'll post the slides. I will. Your stack can be so simple, really. It does not need to be complicated. Now, you probably do want some kind of documentation, and you should have it. If you are a data scientist working on a small team, but still more than one, so let's say n equals 2 to 5, your needs are going to be a little bit more mature. Your stack is going to be more mature. And that is okay. And finally, if you're an enterprise org, well, things like governance, access control, not logs, are going to be super important. They're going to be tied into lineage. And that was a joke. There's no single stack that's going to work there. Sorry. But at the end of the day, whenever you pick an MLOps tool, remember this is what you don't want in your data scientists. You want them to find love, and you don't want to be dependent on whether or not they know all the names of your microservices. You can think of your stack, and you can think about where feature stores fit in very strategically, and I encourage that. So if you don't think feature stores are a good fit, don't use it. Seriously, we all got rent to pay. Just do what works for you. But remember, tooling by itself is not going to solve all these problems. It's not going to solve poor decision outcomes due to bad data or analysis, missed financial goals, delayed innovation. Well, I mean, it should solve that. But a lot of these things it's not going to solve, especially if you engage in YOLO deployment. So like many MLOps folks, I was like, LMs came in, I'm like, whoa, shit, what happened? And yet, the same issues people had about vanilla ML is also with LLMs. Notice the similarities. You can literally just line them up. No matter what though, data is important. Over in the LM land, people are freaking out about the lack of data, about the lack of high quality data we're gonna run out. As data engineers, guess what? You have the opportunity to create that new reality for yourself and your data scientists. And that's the end. I know, just soak it in. It's okay.
Thank you, Mikiko, for the insightful talk. The mess feels real when you show it like that. We probably don't have time for a lot of questions, maybe one. Otherwise, she's around. You can ask questions after the session also.
I am around, and I'm in a pink jacket, so
yes.
I should not be that hard to find.
Okay. Thank you. Thank you.
Okay.